Assalamu alaikum guys, I'm Jubair Ahmed, I'm a biochemistry student and this is a tool I built called Dragforge for drug design especially. So it started with a real problem when I try to start my research in VSc on drug design. Then I face lots of problems as especially in the molecular dynamics simulation. So when I try to start molecular dynamics simulation, I have to install the Gromacs and I face a lots of problems as I'm not a coder, so I don't come from a programming background, and this is why when I try to install there is actually a lots of command that is pretty hard for me, and then we just install the full Gromacs, and after that for running Gromacs as for preparing the protein, solvating, adding ions, minimization, equilibration, production, and etc. So for all this work you have to do a different command line, or you have to just paste a different command line over here. You can take it from Google, but you have to understand what you're doing. You get a lots of error over there, so I face a lots of problem. And then I realize whoever actually biochemistry student, they actually not a coder, they actually not from programming background, and all of them actually maybe face the same problem as I faced. So then I just think about to make an app that will automatically do all this work. You don't have to do any coding, you don't have to just know about every single command or code actually, so you can do in a visual way. This is why I made this app, and today I will show you what this app actually do. So this is my app, the Dragforge, and I built this especially for drug design actually, and here you can see what it need. For now WSL and Gromacs is not present here. I already have WSL and Gromacs in my PC, but this actually cannot detect this because Gromacs actually cannot run in Windows. So I'm in Windows, but you can go for Windows subsystem for Linux also. I will show that, but I need to restart after this, so I will just do that at last. Okay, so here is if you don't install WSL or Gromacs in your PC, also you need Python pandas requester. You can go for settings. This will automatically will ask to if they cannot find any of this, as here is actually a lots of file need to run this app properly. So if they cannot find any of this, they will show you a notification that automatically download all this, so you don't have to take any you don't have to do anything manually. So fully automatically you can download all this. Just click yes, I want to download, and it will download all the required file over here. But for now I already opened this app, so I have to show you from the settings. So if you go settings, and then here is install all dependencies, and you can install all the thing what you need to run this app, as Gromacs and Python 3.11. This actually run on Python 3.11, so this is why you need to download that one. You need RDKit and so other, and if you click on this will automatically download one by one everything. Okay, so let me tell you what this app actually do. Here is my dashboard. This actually have 7 module. So first module actually compound filter. In this you have to give a CSV file. Okay, there is actually a lots of compound in one plant or animal, or you can find a lots of compound. If you take a plant for drug design, as you want to do a drug design from a natural compound, and you pick a plant and you want to just dock it and simulate it against a protein, disease protein actually. So you just have to pick your plant, then you can go any database as Impact or any other database. You can search with that plant, and you get you get a list actually of all the chemical compound present on that plant. So you just have to copy all this compound, then make a CSV file with Excel. This is all you have to do. Okay, you can copy all this compound and then make a CSV file with Excel, and then you can come here in compound filter and go for browse, and you can select that CSV file actually. And if you select the CSV file, those chemical list actually, whatever present in that plant, or you can have all those compound, but those are all compound actually not druggable, as there you can see some fatty acids, some protein, and those are actually not druggable. So you can filter out all those compound what is not supposed to be drug. You can this module actually will filter out all those. Okay, and then you have the refined filter of a compound which can be drug, but still lots of work actually have to do. Then after that, after filtering your compound, you get a refined compound list. Then you come over here and just click browse, and whatever you get, whatever file actually you get from this, you just have to compound filter. In compound filter you just have to select the file, and then you can browse for a output folder, and this will actually save the file in your output folder. So just go for a smile and browse, and then you have to select the results file what you get from the compound filter, and then again select the output folder where you want to save your smiles feature. So this will what this will actually do, this will search every single compound in your list one by one, and will make another file or another CSV where you can get the compound name and the smile structure for that compound. And with that smiles, you don't have to do manually, as like you get lots of compound, and then you have to search it in maybe pubchem zinc, and then you have to find out the smile. And this actually take a lots of time, so I just build this one also, so that this automatically just search all the compound name and take one by one all the smiles, so you can get all the smile at once. Okay, and then after getting all the smiles, you can copy all the smiles at once and then go for Swiss Academy or any other admit website or any other way admit apps. Then you can get admit result, and after getting that admit result, based on that admit result, you can understand which can be drug and which cannot be. Suppose some compound actually over 800 molecular weight, this actually pretty non-draggable, and maybe they cannot be drug, and this is why you have to filter out those compound, as like some compound have log p higher than 6.5, this is not draggable, we say that not draggable, as like you have molecular weight 800 plus, this is also not draggable. So you can filter out those compound, and here is actually let me show you. Here is actually this filter for you can do with RDKit, and you can do automatically with RDKit all the admit, but also you can do with Academy, Swiss Academy. You can make a CSV file from there and you can upload it over here. If you don't want to do manually, you just can do it with RDKit. And also here is actually another selection, as like you can change all of this. Okay, so this is hard filters, so you can choose whatever you want, as like if a molecular weight of a compound is actually greater than 800, then you have to remove it. This is hard filters. If any go over 800 molecular weight, immediately this will filter out that compound. If any of this go over 6.5, immediately that will remove. And this is actually soft filter. You can keep all this under review, all this compound. So we just build this hard filters, and this is actually soft filter. So after the filtration done, you get three files. One is actually a non-draggable, that is actually will save in a removed CSV file, and another is actually kept compound that can be drug, and that is actually filtered out by this soft filters. Okay, so soft filters actually for whichever follow all the rules, this is this is actually by soft filter, so this can be drug, and this is more better compound for becoming a drug. And this is hard filters, that is actually you get another file from hard filters as like under review, so this can be drug, and this also cannot be drug. Okay, so you get as like here is output artifacts, so you get M for accepted, M for review, and M for rejected. You get three files from this admit filter, and after that you can select any of this file. After that you go 3D structure, and then you browse and go for any of this file. You can select any of this file, and you can select another output folder where it save all the 3D structure. It will download automatically all the 3D structure of those compound. Okay, so from that admit filter, you filter out all the non-draggable compound, and you can keep all the draggable compound. And with this 3D structure, you can download automatically all the 3D structure of this compound. So you just have to select the CSV, you select the file output input file, as like I select M for accepted CSV, and then you select a output folder. There all the 3D structure will be downloaded there. Okay, and after that you can do docking over here with this compound, or you can use maybe Autodock Vina or any other apps for docking manually, but you can also do automatically over here. I will try to improve this. I don't know how this actually work. I didn't test it yet, but I will just do manual docking and then do docking over here, and then I will just match the result to check out if this actually working properly or not. But I didn't do it yet, so I'm not going to recommend you to do this over here. And then we have Gromacs. So here is all the selection for Gromacs. Okay, so this is for basic users, so you don't have to select a lots of thing over here. Whoever actually newbie on Gromacs, they directly can go for simulation with some simple selection, as like you can select the protein file, you can select the dock ligand file, and then can run simulation without changing any of this value. Whoever don't know about all these values actually. Also you can only use the complex file, as like after docking you get a ligand and dock ligand actually, and after that you make a complex with that ligand and your protein in PyMol or Discovery Studio. Then you can upload this complex file over here, and that also will go for simulation. and here is actually all the value automatically set, and here you can select which force fields you want. You can type any of force fields over here in custom, and you can select which water type you want. You can just take any box type, and this is actually basic selection. Whoever don't know a lot about Gromacs MD simulation or all this parameters, you can keep it as it is, and then you have to just select the complex, or you have to select the protein or ligand. Then you can directly go for simulation by clicking over here. Also, this will keep the save option as like if your PC crash in the middle of your simulation, then you can start from the last point actually. And for whoever know everything about Gromacs and know all these parameters, for them we have advanced option. If you go for advanced, then you have all this selection as like here you can run the last simulation where it stopped as like PC crash. You can start from here, and here is all the setup, here is the commands, and here is the MDP as like a step, and here is all the selection for that. Whoever actually know everything about this parameter, they can manually select all this and they can choose whatever they want. Here is you can select you want to use your GPU, how many cores you want to use, and every single of this, and some more option, whatever data you want from your and after done your MD simulation, whatever data you want from here. Actually, this is you can select over here as like ligand RMSD, ligand RMSF, and everything. And after that, you need to generate all the results. For that, after MD simulation done, you need all this graph and all this picture, all the PDF or any other file. So for that, we have post MD analysis. So you just have to select the folder where you save all the simulation MD. After you done MD simulation, you just save all the files in a folder. So you just have to select that folder, MD folder, and you have to select the output folder, and this will give you all the results, actually results, so that you can find out, you can actually get all the picture, you can all get all the graphs automatically from this, as like you can get this graphs, RMSD, protein RMSD, backbone RMSD. You can select whatever you want, and this will give you all the results. Let me show you what you can get. I'll already do some, so give me a moment. Let me just open that folder first, then I will so I'll already do some simulation work. Okay, so I'm going to show you that what kind of data you actually can get from this. So here, let me see, yeah, this is the folder. So here is what you get after MD simulation done. This is all the data. Okay, after MD simulation, you get all this data in the output folder, and after that you can run post MD analysis, and you can get all this data, publication package, and here is all the figures. Backbone RMSD is like this. Here is some more backbone RMSD over here. Then you have trajectory, B factor conversion, C alpha RMSD, C alpha RMS, cluster analysis, conformation, cluster, complex radius gyration, complex RMSD. This is all the data you can get from the post MD analysis. So I hope you understand what you can do. I think this default selection is enough for running a normal simulation, and if you know more about it, you can go for advanced, and you can run MD simulation actually more advanced over there. So I think this is it all about my apps. Just leave a comment, did you like this app or not, and I will try to improve this app. And this is mainly for drug design. I will try to make another for network pharmacology also. So I will show you, and I will show you if I make any update. This is it for today. Bye bye.